All right, so now we're ready to add and subtract some rational expressions that don't have the same denominator. So the first thing we're going to have to do is to find the LCD of the expressions, and then write the LCD in the denominators of both of them. Change the numerators to reflect the change in the denominator. Then we're going to add or subtract, and then write the result, and then reduce if necessary. So let's start with example A. All right, so we need a common denominator, so I'm going to write my two fractions there. I can see I need a 3 in it. I need an x. I'm going to choose the larger exponent, which is a 3, and I need a y and no exponent. So then I'm going to copy that over here, 3x cubed y. So now what I'm going to do is I'm going to determine what was multiplied times this denominator to change to this, and I can see that it is a 3 and another x. And so I need to do the same thing to the numerator to keep it balanced. I can't just change the denominator. I must keep it balanced with the numerator. So that's going to give me a 6x there. There's a plus. Then I'm going to look at the second one, 3x cubed y. So that didn't change at all, did it? So my numerator will also stay the same. So now I'm ready to add. So I'm going to keep the same denominator, so keep. And then I'm going to add my numerators, 6x plus 5. And I see a plus there. I can't factor it. There's no GCF, or it's not squares. So this then is just my final answer to that problem. B, they do not look, the denominators do not look the same, but I see that they are opposites of each other. So what I'm going to do is I'm going to factor a -1 out of this one. It's going to turn the order around to make it x minus 1. So the easiest thing to do with this is to slip this and put it to the numerator. So rather than leaving it down here, just move it to the numerator, so that now really what I have is 2x minus 6 over x minus 1, then minus, and I put that up there, a -4 over, and then x minus 1. So I've got the same denominator, and that's going to give me 2x minus 6 minus a minus is going to give me plus 4. So then that's going to be 2x minus 2 over x minus 1. And I always want to think about reducing at the end, and the fact there's 2's in both of those, that's very easy to factor out. And so that's going to leave me with 2 times x minus 1 over x minus 1, and those cancel, and my answer is 2. So again here, x plus 2 and x minus 2's are different denominators. So my common denominator then is going to have both of those in there, x plus 2, x minus 2, and over here, same denominator, x plus 2, x minus 2, and there's a plus here. All right, so then I need to change my numerator, so I'm going to notice that I multiplied this by x minus 2. So I'm going to do the same thing here, x minus 2, and that's going to give me, I'm going to distribute and get 3x minus 6. And on the right fraction, I'm going to multiply it by x plus 2. So I need to make sure I get the what's missing down here, and then do the same thing in the numerator. So that when I multiply, I'm going to get 2x squared plus 4x. So that when I add them together into one fraction, my denominator is x plus 2, x minus 2. I'm going to add these as I go. I'm going to add these all up. So it's going to be a 2x squared from this right here. I have a 3x plus 4x, so it's going to be plus 7x, and then minus 6. So we don't know if that'll factor or not, so let's just give it a try. I'm going to get negative 12, so I see 2 and 6. That'll be a 3 and a 4, but that one of those has to be negative, so those really add up to 1. and 12 and 1. So none of these are going to add up to 7, and so we are now finished.